Growing up in poverty is associated with a heightened risk for mental and physical health problems across the lifespan, and there is a growing recognition of the role that social determinants of health play in driving these outcomes and inequities. How do the social conditions of poverty get under the skin to influence biology? And through what mechanisms do the stressors of poverty generate risk for a broad range of health problems? Before we start, here are some questions for you to think about. Does every child have the same starting point? What does being raised in poverty mean for a child? What do rich kids benefit from their family aside from material support? Today, we are going to look at anger, fear, sadness, and their relations to socioeconomic status and the amygdala. So what do we already know? Socioeconomic status has a well-established relation to cognition, measured by academic achievement and intelligence tests. Evidence concerning SES and emotions in healthy individuals is both limited and mixed. Most previous research has been focusing on individuals with clinical syndromes or mental health issues. In this study, the researchers want to see if SES has any effect to emotions and amygdala for healthy individuals. The researchers have proposed 3 hypotheses. First, are negative emotions more pronounced among healthy individuals of lower SES? Second, do the structure and function of the amygdala, measured in terms of volume, reactivity, and FCC, vary by SISC? Third, does amygdala structure or function account for SES differences in negative emotional states? In order to test these, researchers have used the publicly available repository of the Human Connectome Project, S1200 release, which includes 961 healthy young adults, aged 22-35. These individuals broadly reflected the racial composition of the U.S. population. Here are some of the measures that were used in this study. SES level is calculated by combining scores of income and education for every participant. Negative affect is a subscale of the NIH Toolbox for assessment of neurological and behavioral function. Participants were asked to report their level of anger, fear, and sadness using this scale. For brain imaging, resting fMRI is acquired. Amygdala reactivity was acquired when participants performed an emotional face matching task with a shape matching control condition. Participants are shown a facial expression on the top and are supposed to find the matching facial expression from the bottom too. The dependent variables in this study are amygdala volume, reactivity, and its functional connectivity. Negative affect is also a dependent variable here. For independent variables, SES is the major one. Some covariates that are used in this study include gender, age, and race, along with the within-subject factor of hemisphere for the imaging-dependent measures. For the method, SES-related analyses are conducted. For the emotional aspect, they composite negative affect score and anger, fear, and sadness scores. For structural MRI is done to compute left and right, amygdala volume. For functional, amygdala FC is analyzed to 3 prefrontal regions whose connectivity varies by SAS, VMC, VELV-C, and SFGA, the first 2 of which play important roles in implicit and explicit emotion regulation, respectively. So what did the researchers find? First of all, for SAS, an effect, a negative correlation has been observed. The lower SES is, the higher negative effect is. In terms of specific emotions, anger shows the biggest effect, followed by sadness and fear. For amygdala volume, reactivity, and functional connections, amygdala volume shows a small but yet significant effect. However, results for reactivity and FC are non-significant. Negative effect was found for reactivity. There is a possibility that amygdala can be considered a mediator for the SES negative effect relation. However, results have shown that SES effect relations are stronger when amygdala volume is accounted for, and people of low SES do not experience more negative affect because of their amygdala volume. They experience more negative affect despite their amygdala volume. So what can we conclude from these results? The results provided strong confirmation of the hypothesis that normal healthy individuals of low SES typically experience more negative affect than their higher CS counterpart. The mediation analysis failed to show a mediating role for amygdala volume in the SAS negative effect relation, instead revealing a suppression effect. There are some limitations to this study as well. Participant age may play a role in the ways that SES is manifested in brain and effect. Much of the literature on SES and the brain concerns children and adolescents. The effects of SES may depend on developmental stage. Secondly, what does SES mean? What does poverty mean? There are so many different ways to define and measure SES. The current study only examines SES through education and income. There might be better ways to measure poverty and SES. For future studies, the published findings reviewed here illustrate the challenge of replicable research in the behavioral and neurosciences, particularly regarding complex social attributes like SES. This field is still at its early stage of development, with its early experiments only dating back to 2008. Consistencies in measurements have to be established. Some of the major take-home messages for this study. Even normal, healthy young adults report on average feeling more negative emotion the lower their SES. There is a positive relation between SES and amygdala volume. Nevertheless, poverty is a crucial problem in our society that is serving as a huge risk factor for one's emotional and functional development.